So very first thing in this case is, okay. So I welcome you for this lecture, and today we will be discussing about minimum number of teeth, then face width, and followed by force analysis. So let us start with minimum number of teeth. The formula, if you can see, for minimum number of teeth is given by Z minimum. So the notation is used Z minimum. Many times in your machine design one and other aspect, the terminology or term theory of machines 1 to whatever you have studied, you might be using the notation as T, T for teeth. So remember, in this machine design second, we will be using the terminology or the number of teeth, whatever the teeth is mentioned, the terminology used is Z. So Z minimum is equal to 2 divided by sine square alpha. This is the theoretical formula. So 2 is the number, Z minimum is the minimum number of teeth which should be present on the pinion so that to avoid the interference and undercutting. And alpha is the pressure angle. So it depends upon the pressure angle. We have discussed two different types of systems: 14.5 full depth involute system, 20-degree full depth involute system, and here one more shown is 25-degree pressure angle also shown. So if you put this alpha in this particular formula, you will get the Z minimum theoretical as, for 14.5 degree, 32 minimum number of teeth are required on pinion to avoid the interference. For 20 degree, 17 number of teeth are required to avoid the interference, and for 25 degree, 11 number of teeth are required to avoid the interference. So these are the some theoretical formulas. So 32, then here 17, and here 11. Now if you see Z minimum practical, so instead of going for 32, by slightly changing the fillet radius and giving corners at the top of this particular gear profile, so slight modification in the gear tooth profile form, if one can go for, then this minimum number of teeth can further reduce up to 27 for 14.5 degree full depth involute system. Then instead of 17 for 20 degree full depth involute system, we have discussed the advantages of this system also. This system is widely preferred over 14.5 full depth involute system. The teeth are stronger, the teeth is broader at the base, therefore high load carrying capacity, high load transmission. These are the advantages we have discussed for 20 degree. So it is most widely used system, 20 degree full depth involute system. And if some slight modifications are made in the tooth profile, then these teeth can be reduced up to 14. And for 25 degree, 11 number of teeth are required. It can be reduced up to 9. So once again, I will repeat, minimum number of teeth is these are the teeth required on the pinion to avoid interference and undercutting. So what is interference? The teeth on the pinion will dig, will go into the dedendum part. Huh? Will go into the dedendum part, and I request all to mute their. I request all to mute their so that no disturbance will be there. Okay, so we are discussing about the minimum number of teeth concept. So minimum number of teeth. So these are the theoretical things which are required, and the minimum number of teeth given by the formula, it is different, and by practical means by slight modification in this particular point, it is something different. So this 27, 14, and 9 are the after modification minimum number of teeth are required. So for 20 degree, you keep in mind this is very important, most usually system. So for this 17 and 14 are the minimum number of teeth required on the gear tooth. Okay, so this is one consideration, and this is the formula for minimum number of teeth on pinion, so that no interference will be there, and no interference Therefore, no undercutting is required. So, what will happen in interference? So, in interference, the teeth will dig. One teeth will, the teeth on the pinion will dig into the teeth on the gear, and some at the teeth get attached, and it will digging some material from the gear tooth. So this happens, and this will ultimately lead to we have to go for undercutting operation. This we have already discussed in the previous lecture. So this is the concept of minimum number of teeth. Next, very important concept. Next, face width. So in the terminology itself, we have discussed what is the face width. It is nothing but the width of that particular gear. So in the design of gears, it is required to express the face width in terms of module. Very important. Face width, it is denoted by B, but in design of gears, there is a correlation between the face width and the module. So face width is required to be expressed in terms of module. Okay. In the Lewis equation means beam strength equation that we will be discussed today afternoon. So it is assumed that the tangential force PT is uniformly distributed over the entire face width. Whatever the force acting on the gear or whatever the force acting on the pinion is uniformly distributed. The force is uniformly distributed over the entire face width. Now, there are two chances. The face width should not be too large or the face width should not be too small. See, the face width should not be too large or the face width should not be too short. So what will happen if the face width is too large? It is possible, or there is a possibility of concentration of load at one end of the gear tooth due to number of factors like misalignment may be there, elastic deformation and warping of the gear tooth. So if it is too large, then there are chances that, for example, I will give you here. This is okay. This is gear tooth. So what is the face width in this terminology? I will call that this distance to this distance. So friends, this is the face width. It is denoted by terminology B. It is expressed in terms of module. So B is expressed in terms of module. So sometimes of module. So that we will be discussing in next slide. What should be it? So this PT is uniformly distributed. The tangential force is uniformly distributed over this complete area where the PT is acting. And if the face width is too large, assume that the B is too large. The gear is not like this. The width is like this unnecessarily. Then there are chances that the concentration of load, the load will be concentration at any one point. The load will be concentrated at any one point of this, and the load will not uniformly distributed. Okay. On the other hand, if the gear face width is too small, assume that the face width is not like this. This is only half part. Okay. This is only your face width. Okay. So smaller part. So what will happen in this case? The small face width will have poor capacity. Small face width, smaller dimension, poor capacity to resist the shock and absorb vibrations. They will also wear at faster rate. Therefore, a narrow face width result in coarse pitch. So narrow face width is also not desired. So if it is too large, not desired. If it is too small, again not desired. Both are not desired cases. So what is the exact formula required for this? In practice, the optimum range of face width is taken from 8 times of module to 12 times of module. The face width is denoted by B. So 8m less than B less than 12m means face width is taken from 8 times of module to 12 times of module. In the design calculation, we have to express face width, that is B, in terms of module, so that the whole equation will get converted into module. We will calculate the module, and after that calculation of module, we will put in the formula B is equal to, for example, 10 times of m. So you will get the face width answer also. So it is requirement of that particular Lewis equation to express the face width in terms of module. Therefore, I have explained you why it should not be too short. Again, why it should not be too long. What will happen if it is too long and too short? Then this is the optimum range of the phase width. That 8 times of module to 12 times of module. And in general practice, it is assumed as 10 times of module. So B is equal to 10 times of module, where B stands for the phase width in millimeter and M stands for the module in millimeter. So I request you to note down the formulas wherever required. So the last case also, you can write that minimum number of teeth. Z minimum is equal to 2 divided by sine square alpha. And again this phase width B is equal to 10 times of module. Okay, so up to this, I assume that everything is clear in the initial stages of gear design. Wherever there is phase width is not given, we will assume that this phase width is equal to 10 times of module. We will put in the equation and we will proceed further for calculation. Okay, so this is all about the minimum number of teeth desired and phase width. Now next, very important and some different concept in this terminology, hunting tooth. The name only is somewhat different. It is written as hunting tooth. So let us try to understand what is the concept of this hunting tooth. The concept hunting tooth is for uniform distribution of wear tooth. Very important here. So the objective type question may be raised about the use of hunting tooth. So answer should be for uniform distribution of wear, the hunting tooth is provided. Now I will give you example. What is written here? For example, ZP is equal to 20 and ZG is equal to 40. ZP, number of teeth on pinion are 20 and number of teeth on gear are 40. And the pinion and gear are rotating. Okay. So number of teeth on pinion is less. So when the gear will rotate one time, 40 number of teeth, the pinion will rotate 2 times. Very simple. When the assume that this is smaller pinion and you can say this is larger gear, for example. So when the gear will rotate only one time, the pinion will rotate 2 times. This is the simple logic here. Then after every 2 revolutions of the pinion, the same pair of teeth will engage. So for example, you mark any one pair that this pair is engaged now. For example, you mark here now that this pair, this is a pair, there is a pair. So this teeth on pinion and this teeth on gear engaged. So now the same teeth after 1 revolution again not engaged. After 2 revolutions of pinion and there will be 1 revolution of gear, and the same teeth or the same pair which have made before 2 revolutions, which they will mate again. So this is very important concept you have to understand here, that if the number of teeth on pinion are 20 and number of teeth on gear are 40, then after every 2 revolutions of pinion, the same pair of teeth will engage. Okay, so this is the first concept. If this concept is understood, okay, no problem. Then now, 1 teeth is added in the gear. See now, however, we take ZP is equal to 20. ZP, no problem. ZP, it is 20 only. ZG, number of teeth on gear are taken as 41. 1 teeth is added. See here, in the previous case, it is 40. In the current case, it is 41. So 1 teeth is added in the gear. Now, the pinion and the gear, after 2 revolutions also, they will not, the same pair of teeth will not engage. The pinion has to rotate for 41 times, 41 revolutions the pinion has to rotate for engaging the same pair of teeth. Very important, for engaging the same pair of teeth. And this concept gives you the rising of hunting tooth. So that 1 additional tooth, whatever the extra tooth provided, it is called as the hunting tooth. And why this extra teeth is provided? More even distribution of wear. Assume that there is a wear or at any particular teeth. Then if the teeth is coming in contact with the another mating pair after every 2 revolutions, it will, you can say it will corrode or it will wear at faster rate. But the whatever teeth is having some problem, some deviations, some errors, or you can say wear on that particular teeth, then if the teeth is not coming in contact with the same another pair for 41 times, so less or even distribution, wear will be there, but If means instead of wearing only one pair, all teeth will wear slowly and life will increase. So this is the uniform distribution of wear tooth. So what is happening? Once again, I will summarize that if ZP20 and ZG40, then after every 2 revolutions of pinion, the same teeth of pair of teeth will engage, and if one teeth is added, this 40, it will become 41. If only one teeth is added in that particular gear, then in this case, what happened? The same, for engaging the same pair again, the pinion has to rotate for 41 times. This is very important. Pinion has to rotate for 41 times. And why this is happening? This is due to only the addition of extra tooth, additional tooth, and this tooth is called as the hunting tooth. This is used for even distribution of wear. This is used for even distribution of wear. So, friends, this is the concept of hunting tooth. Let us move further. Force analysis of spur gear. Now here, in this particular force analysis, there will be some diagrams. I request you to draw the diagrams and then we will proceed further. The force analysis is very important because this spur gear force analysis is understood. Then there is one more factor added in case of helical gear, and again further tooth analysis. And whatever the formulas, whatever the things which we are discussing for spur gear, all things will remain same for helical gear also. Only one component will be additional in helical gear. So this is very important concept of force analysis of spur gears. So friends, the pinion and gear are rotating. Pinion is driver. What is mentioned here? See, pinion is driver and the gear is driven. So in this case, the pinion is rotating in a direction as shown in figure, anti-clockwise direction, and the gear is rotating in clockwise direction. Then in this case, if pinion is driver, the teeth of the pinion will exert a pressure or force on the teeth of the gear, and therefore, due to this force only, the gear is moving, the gear is rotating in this direction, because this teeth is adding, this is pinion is rotating in anti-clockwise direction, and this teeth is forcing the another teeth of the gear, and due to this only the gear is rotating. This is very first point to understand. Then second, whatever the force is applied from one gear to another gear, it is always applied along the pressure line. The pressure line is nothing but the where the angle alpha is made. Alpha is pressure angle. So therefore the forces or whatever the force will be there, let us assume that the force is Pn. So Pn is the resultant force acting on the gear teeth pair. Pn is the resultant force acting on the gear tooth. So this teeth is exerting the teeth on the pinion driver is exerting the teeth on the gear or driven, applying a force Pn, resultant force Pn as shown in this diagram, and the gear is rotating in clockwise direction. So pinion is rotating in anti-clockwise direction and gear is rotating in clockwise direction, and it is along the pressure line always. So these are the two pitch circles shown, and whatever at center it is shown, it is the pitch point shown. So this is the force analysis diagram. In gear, power is transmitted by a force exerted by the tooth of driving gear on the meshing of driven gear. The teeth of this teeth of driving gear on the meshing teeth of driven gear. This is I am explaining. See the cursor. This is the teeth of driving gear and this is the teeth of driven gear. And this figure is shown that it is total force is Pn. It is the resultant force, and due to this force only the gear is driven. According to fundamental law of gearing, the law of gearing you have already studied. So according to this law, the force, resultant force Pn is always acting along the pressure line. Is always acting along the pressure line. So I request you to give the heading in your notes as force analysis and draw this diagram. Okay, this diagram. So this diagram is very important. We first draw the diagram, then we will discuss about this. What are the assumptions made and what are the different formulas for force analysis, and we will continue further. So take 3-4 minutes